Yeah, you can hear me. Okay, good. Hi, everybody. Good morning. That was terrible. Just terrible. Let's try again. Good morning. Good morning. Ah, thank you. Much better. Good stuff. My name is Josh Long. It's so very nice to be here. This is my second time here. I was lucky enough to be at the very first Vox Days CERN in 2017, 7 long years ago. It feels like yesterday, though, because there's that odd pandemic in the middle. But I'm just very happy to be here. You know, the last time I was here, it was, again, 7 years ago. That means that my speaking career has doubled since then, right? It's just an incredible length of time, but I remember it so fondly. And I'm very, very happy to be here because I feel like we're in the middle of star stuff, you know? How do we get to the stars from here? I just feel very lucky to be here. So I'm very, very happy that you're all here as well. I was wondering if we could take a selfie. Is that okay? Okay. Pretend like you're happy. Pretend like you're happy. Okay. Ready, steady, say open source. Thank you very much. I appreciate that. I will show that to my daughter and I will say, see, they listen to me. Okay, good stuff. My name is Josh Long. I work on the Spring team as a Spring developer advocate. I'm a Kotlin Google developer expert and a Java champion, and I am at your service. So should you have questions, you can find me on the YouTubes. Who's using YouTube? YouTube, very good. Find me there. I've got a channel. It's not terrible. It's not the worst mistake you could make today. There's code there that you can follow along with there. I have email. Who's using email? Does anybody use email? Email. No, good. Moving on. And I've got that bird website is on fire, but if you're still on there, then you can find me there as well, okay? I'm happy to engage. All right, so my friends, today we're going to talk about the latest and greatest in the Spring ecosystem. Well, at least some of the latest and greatest. We've only got, 45 minutes, something like that? When is my next timer? Right? No timer set. Oh, lies. Well, anyway, we've got very little time, so we're going to go as quick as possible. We couldn't hope to capture it all, but we're going to give it our level-headed best attempt. And friends, I feel like there's never been a better time to be a Spring and Java developer. I feel like we are at a unique moment where the growth of the Spring technologies plus the growth of Java have sort of converged and put us in a place where it's just an amazing time to be a developer today. We have so many good things going for us, and I want to just talk about some of that, right? I think these things play off each other. It is, this year is 2024. That means we are 10 years since Java 14, right? 10 years since Spring Boot 1.0. In April, it'll be 10 years. And actually last year, we celebrated 20 years since the first early access versions of Spring Framework and 10 years since the first early access versions of Spring Boot. And so you can go to spring1.io/history of Spring. You can see the long extended history there of all this stuff, right? And so you can see, go down here, Spring Data 2011, Spring Boot 1.0 2014, 2014 Spring Batch 3.0 with Spring Boot autoconfig, Spring integration. Go up here into the clouds, get it, cloud computing, Spring Cloud 1.0 2015, Spring Cloud Task 2016, Spring Cloud Stream 1.0 2016, Spring Cloud Data Flow, going back down now, more of the maritime water theme. So we got Kubernetes, right? Spring Cloud Data Flow for Kubernetes, Spring Cloud Skipper. We've got Spring Cloud Gateway for Kubernetes. We've got Spring Boot 3.0 in 2022, Spring Boot 3.0 and Spring Framework 6, very important releases. And of course, that brings us more or less to the present day. This was done middle of last year. And so, we celebrate 20 years since the early access builds of Spring Framework in 2003. So it's just an amazing time. So I say that today we are at an amazing place. There has never been a better place to be a Java and Spring developer. I say that fully aware and having had the experience of living those 20 years with Java and Spring, I say that with all that background. It's an amazing time. And so let's just get into it, friends. Let's just try and build some software as we always do. Here are my second favorite place on the internet. My first favorite place on the internet, of course, is production. I love production. You too should love production. You should go as early and often as possible. Bring the kids, bring the family. The weather is amazing. It is the happiest place on earth. It is better than Disneyland. But if you've never been to production, you can begin your journey here at start.spring.io. So we're going to build some new software. We're going to build some new software here, friends, and we have some choices that we need to make. First of all, what build tool? I'll use Maven. Sure, you can use Gradle. What version of Spring Boot? I'm just going to use the latest and greatest. Uh-oh, I wonder if that's new. We might have to download some dependencies. Hopefully, the Wi-Fi here at CERN, where they invented some of the technologies that go into Wi-Fi, will be fast. We'll find out. I'm going to give it a group name, and I'm going to call this service. Okay, I'm going to call it service, and the reason I'm going to call it service is because I'm really good with names. Amazing with names. I get that from my father. My father was amazing with names. When I was a child, we had a small white dog as a family pet, and my father named him White Dog. Now this dog, this dog, I swear, he was with us for like 10 years, and then he disappeared. But I was a child. I don't know what happened. Maybe he got a job. I don't know. But then a few weeks later, or a few months later, another small white dog showed up at my family's home and tapped on the door looking for a place to stay. And my father named him Two. Now, I'm not sure if that's T-O-O or T-W-O. If my dad were still alive, I would ask, but I don't know. But either way, great with names, really great. But that said, my mom, she tells me all the time, she says, "You're very lucky that I named you." And yeah, that's probably true. So anyway, service. And then, friends, we have a choice about what version of Java we want to use. Friends, in order to use Spring Boot 3.x and later, you must use Java 17. But actually, this would be irresponsible in today's world, since Java 21 is already here, right? This is very irresponsible. There's no reason to use this. To use Java 17 when you could use Java 21 is to throw away your organization's money. You see, Java 21 gives us optimizations that make it just insurmountably good. It's just way better than Java 17, and we'll talk about some of those today. But to use this is to be negligent, right? Don't use Java 17. It's ancient technology. It's from 2 years ago, right? And it's certainly a lot better than Java 8, but it's just very, very out of place now. It has no place today. Java 21 is technically superior than Java 8 in every conceivable way. It's faster, more robust, more syntax rich, more secure, more performant. It's technically better. It's also morally superior. You won't like the look of sadness and shame in your children's eyes when they find out you're using Java 8 in production. Don't do this. Be the change you want to see in the world. Do the right thing. Use Java 21 or later. And friends, we're facing down Java 22, which is going to bring, I think it brings Project Panama, right? The vector API, SMIDs, all that cool stuff. So there's really no reason to be using these antiquated older versions of Java anymore. It's technically superior, like I said. It's also morally superior. And if I haven't yet persuaded you, then I think we can all agree, judging purely by the version number alone, that Java 21 is almost 3 times as good as Java 8, right? I think that's a fact. It's basically a fact, right? So we're going to go ahead and leave that there, and we're going to add some dependencies to our project. We're going to build a new application. I'm going to use Postgres. I'm going to use the Docker Compose support. I'm going to use Actuator. Nah, we don't need that for now. We don't have enough time. We'll use the web support. We're going to use the Spring Data JDBC support. We're going to use the GraalVM-native image support. We're going to use dev tools for live reloads, right? There we go. And so I've got a number of different dependencies here. I'm pretty satisfied with my selections. Let's hit generate, and we'll open this up in the IDE, okay? So did I download that? Here we are. Can you see that in the back? All right, I'm going to load that in the IDE. Like I say, I think there might be a new version. We might have to do some Maven installing here. Let's see what happens. Oh, Wi-Fi. Okay, whoever's Bitcoin mining, would you please stop? Let's see. Oh yeah, skip test. There we go, it's fine. Don't worry, you didn't see that. You didn't see that. All right, so we're going to build a new application, friends. We're going to build an application. This is a data-centric application, so I want to describe some data. So I'll create a record to describe my entity here called customer, okay? Now, I love records. How many of you have been using records here, right? Records are amazing. Records are amazing. I love them so much, right? Just so much better. So I'm going to go ahead and use that. And records are just a nice thing. They give you the ability to describe your objects, and they provide a simple contract, which is the identity of the object is equal to the identity of the components of the record, right? Records are tuples, basically. in other languages, but they're nominal. Java is a very nominal language. That is to say, we care about names. So records are tuples with a name, okay? And the language gives you a lot of benefits if you agree to that contract. You say, this thing is equal to the identity of this thing, and therefore we can establish a constructor, field storage, a toString, equals, and hash code, all for free if you use that record type. Okay? This is great for what we want. And by the way, there are many other features in Java 21 and later that serve this use case. I think there's one talk on the schedule around Java 21 and data-oriented programming, right? This is Brian Getz. He talked about the Java language architect, Brian Getz. He talked about this in 2022 in an InfoQ.com article, data-oriented programming. Historically, Java has been very, very successful in the world of the monolith, because it's got this good type system, good compiler, access controls, privacy controls, all this stuff that makes it easy to build deep-rooted hierarchies of polymorphically dispatched types. It makes it very useful to work in that use case, in that monolithic use case where you're sending change, you're communicating change through subclasses, right? That's how you express different dimensions of the system. But now, increasingly, we're not building deep hierarchies of polymorphic types. We're instead building smaller code bases with smaller hierarchies, and we're communicating change by sending messages, data, right? That data is coming in from the network, from REST, from Kafka. We're dealing with records. We're dealing with little objects being flung around the code base, and that's how you communicate changes in the system. So the language has to evolve to support that. So now Java 21 has a bunch of features that were slowly introduced in the last several years, but that culminate in Java 21, including sealed types, pattern matching, switch expressions, and record. So let's take a simple example. Let's suppose you're working in a heavily regulated industry and you want to create an object to model a loan, a financial instrument that is usually regulated heavily in an industry. Well, let's say I have a secured loan and I want to implement loan, right? Okay. And let's say I have an unsecured loan as well. Okay. So I've got now two different kinds of loans, and I want to describe these. I want to provide a message to the user based on the kind of loan they've got. Okay. So string message for loan. There we go. L. And what if I wanted to do this? I can say, okay, if L instance of secured loan, okay, then I can provide so I can downcast like this, I can do that, and then I can say, okay, if it's that, then maybe I provide a response, okay, maybe, okay, good job, here we go, good job on getting the secured loan, right? Okay, there's that. What about the other one? Okay, well, if L instance of unsecured loan, okay, var USL unsecured loan, L, okay, return, oh, too bad. Okay, right, and so now I've got that, but those are the only two cases, right? I've got these only two types, and yet the compiler's not satisfied that I've exhausted every possible situation. So I have to return I don't know, maybe just throw an illegal argument exception or something, right? Oops, should never be possible to get here. But I want the compiler to help me with this. So what can I do? Well, I'm going to make this a sealed type, okay? That's the compiler telling me, give me a way to enforce that there's only two implementations, because the last thing that I want is for somebody to create an anonymous interclass version of this type, right? And so now I have to seal the hierarchy. Well, now the compiler knows that there's only two implementations of this. I don't want, for regulatory reasons, I don't want somebody passing in an anonymous interclass that implements loan and trying to sidestep the compiler and sidestep the regulatory checks that we've got. But the compiler still isn't happy, right? If I get rid of that, not good. So what can I do to make this a little bit better? Well, what if I did a smart switch expression, right? Switch L, and now I can use pattern matching. I can say, okay, if it's an unsecured loan, and look at that, I can assign it to a variable, then I can do this as well. I can say, pass that in, right? Good. And then I can do case secured loan, SL, and I can pass that in. So I get rid of this, all this code here. All right, oop, too bad, paste that in. And now this is all, first of all, it's cleaner, and second of all, I don't have to handle any other case. The compiler knows that I've exhausted all the possible cases, and so it's going to help me here. And actually, what if I don't handle the case? What if I comment this out? Look at that. The compiler is saying, hey, this isn't valid. You haven't covered all possible input ranges, basically. right? The compiler is helping me capture possible subcases, and I'm using pattern matching here to extract a variable out. So maybe I can say that interest rate is high, right? And then I can pass in some sort of interest rate. Well, what interest rate? Well, I've got this UL. Let's just say that we have a field here, okay? And let's go back to the unsecured loan here. I'm going to turn this into a record. So float interest rate, right? There you go. So now I can do that. I can provide that interest rate in there. But actually, with the pattern matching, the language knows what the constituent components are. So I can even go one step further. I can extract out just the component that I want and use that here, right? I'm extracting out from the pattern the constituent components and putting them into their own variable in the scope of that cast. Isn't that amazing? The language is making it easier and cleaner to do the right thing. This is Java 21. I'm not showing you another language. I'm not showing you something that'll come in 5 years' time. This is today. You can do this yesterday, 6 months ago almost, you know? So the language is really amazing. So even though I'm doing this silly little thing, don't sleep on records. They're amazing. They're part of a whole package of amazing features designed to make it easier to work with data, okay? So I'm going to create a customer repository, extends list of CRUD repository, managing entities of type customer whose primary key is of type integer. And I want to have some data in the database. So I'll go here, source main resources, and I'm going to create a schema.sql file, and I'll describe the table that I want to create called customer, ID, serial, primary key, name, text, not null, okay? And I want to have some data as well, so I'll go here and I'll say data.sql, and I'll say insert into customer name, and I'm going to put some people who are on the Spring team, okay? Just people in the community that are awesome in the Spring team itself. Olga, Dr. Stefan, look at this. You wouldn't know I'm an American. Look, I know accents, huh? Huh? Amazing. Jürgen. Huh? Look at that. First try. First try. Amazing. Props are in order, I think. The good Dr. Sire. Can't even spell his name. That's not good. And then Spencer. Sure. Spencer. Okay. And then I'm going to go up here. I'm going to, delete the data just to reset. Okay. And I want to tell Spring Boot to reinitialize the database each time when the application starts up. So there's the application. Now remember, when I went to the initializer, I chose Docker Compose. And what that did was it added the Spring Boot Docker Compose support, and it created a Docker Compose file for me automatically on the Spring initializer. So I'm using Postgres. It's created a Postgres data source for me right there, right? And now I'm going to restart the application. It's going to take a little while. Let's go ahead and run this, okay? So I'm going to go ahead and run it. It'll download the Docker image for me. And you can see it's actually, look at that. It's downloading the whole thing. Right? It took a long time, 2.1 seconds to start that up because it had to download the Docker image and then run it, right? So this is not good. I don't want to wait this long. I don't have all day, right? I want my code, I want to be able to git clone and run and move quickly. This is good for that, but it's not good for cycle time. And so I've also added the dev tools. The dev tools give me the ability to make changes to the code while the program is running. So I make a change and then I recompile. I don't have to restart. Because Java is many things, but fast to start up it is not, right? And so what the dev tools does is it keeps the JVM warm, but it recreates the Spring application context. Each time you make a change, it recreates the Spring application context, throws the old one away, and it creates a new one with the new classes in the class loader, right? That way, it's much faster, unless you're restarting a Docker image every single time. Right? And so what I want to do is I'm going to go here and I'm going to go to my property file and I'll say Docker Compose lifecycle start only. Okay? So now I'm going to restart one more time. Good. It'll start and it's not going to restart. It's not going to stop it each time. So it'll just start it, and if it's already there, great. And now I can make a change. Okay, stop that. Now I'm going to make a change. I'll create a customer controller. Okay? Private final customer repository, inject that, add that to the constructor, git mapping customers, collection of customer. Okay, return this dot repository find all. Good, and simple HTTP controller at response body. And now I want to restart the code. I'm not going to rebuild it. I'm not going to restart the JVM. I'm going to recompile. Command Shift F9. Okay, recompile. So when I do that, this time it just does the compilation, and this time it starts up in 0.3 seconds. Right. So now I'm making my changes. I'm seeing them reflected here almost instantaneously. Voila. Okay, it worked. Of course it worked. It was a demo. That was always going to work. So now, friends, I've got data in the database. I'm moving quick. Good stuff, right? Good stuff. Now, this is, by the way, a Safari issue. The accents, right? And go here. I don't know why Safari hasn't figured out accents yet, but that's a little embarrassing. I figured it out. Safari should too, right? Okay, so now I've got my applications up and running. This is all pretty stock standard stuff. The difference is that we're moving quickly. But this is basically what you could have done 10 years ago. Web app talking to database, okay. But things have changed. There's always new stuff. Here, we're standing in the middle of the sort of the center of science on the planet, right? How we get to Star Trek from here is here, right? And so I feel like we have to embrace the latest and the greatest. And one thing about which I'm sure you've no doubt heard is artificial intelligence, because clearly the search for intelligence was not hard enough, and so we're looking for artificial intelligence now. And so we have a project called Spring AI that we launched last Spring 1. We announced it publicly, right? So let's go ahead and incorporate that. It's not yet GA, but it's really good. So talk ai.md. I'm going to copy and paste the Maven definitions here. So we go here, paste, and I've got the dependency there, Spring AI. This is the experimental project. And we're going to add this dependency in the repository as well. So repositories, voila, okay. I'm going to do Command-Shift-I, so I'm changing the class path, basically. So this requires a full restart once it's downloading the dependency. Okay, here we go. Internet, come on, internet, go, 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 good. Okay, Command-Shift-I. I'm going to do a full restart, have to wait that agonizing 2 seconds again. Not good, but hey, that's life. Okay, and now I want to make a change. I'm going to use that AI to, ask it a question, okay? So let's say story controller, okay? Private final AI client singularity, right? Isaac Asimov would have appreciated this. Good, so now we're going to create an endpoint here, and we're going to ask it a simple question. Tell me a story, okay? Map string story, okay? Return map of, okay, story. And I'm going to use the AI. I'm going to first of all, I have to give it a prompt, right? There's a whole discipline of prompt engineering. By the way, multi-line strings, Java, good stuff, huh? Look at that. Now I can do SQL, and very importantly, I can talk to my AI. So, dear singularity, it's important to be polite. They will remember. Would you please tell me a story about the wonderful CERN Research Center in Geneva, actually in Switzerland and France, about its wonderful people, the local food, and the amazing culture. Also, please write it in the style of famed children's author Dr. Seuss. Now, Dr. Seuss is one of my favorite doctors, along with Doctor Who, Dr. Strange, Dr. Venkat Subramaniam, Dr. David Sire, Dr. DeVolder, and so on. And cordially, Josh. Okay? Now, it's very important to be, again, very important to be polite. I have to specify also a Spring AI, OpenAI key. And I've already done that, friends. I've already done that. What I did is I exported an environment variable like this in my shell, and it's in my environment. Now, forgive me for not leaking my OpenAI credential, but just trust me, it's there, okay? So there's that. I'm gonna make a request now, okay? So var response equals this dot singularity dot generate, pass in the prompt, okay? And then the response, I'll put it here. Good. So Command-Shift F9, okay, go back here, it's done. And we go to story, and now we ask it a question. I mean, to be fair, this is still faster than I could write the story, but it's not great. Okay, there we go. There we go. Oh, hello there, Josh, my dear. I'm Singularity, and I'm here to make it clear. I'll tell you a story, a tale so grand, about CERN, a place in Switzerland, and France land. What? What? At CERN, scientists gather, their minds so bright, to study particles day and night with big machines like the mighty LHC. They explore the secrets of the universe, and you see, the people at CERN are a curious bunch. They search for knowledge with a fervent hunch. From engineers to physicists, they all play a part in unraveling the mysteries of science. Oh, so smart. You get the idea. It can tell stories. It can write poetry. We live in an age of miracles. So, friends, I made that request. I talked to the Singularity. I got back a response, which just blows my mind. But we had to wait. There was some awkward time there. I could have drank some water like this. It took a long time, too. That's a little problematic. It's not a big deal for us because we knew we had to wait. But think about what's happening from the perspective of our service. We're building this application. The application's running on a web server. We sent an HTTP request into the servlet container. The servlet container got this servlet request, and it launched a thread. And in the thread, it then calls our servlet, which is Spring MVC behind the scenes. And then the Spring MVC was used to provide the response. But we provided the response by calling the OpenAI API, right? And that resulted in us making a call over the network. Well, that network call was a blocking call. We're using input_stream.read. So we're wasting time. We're using input_stream.read, which means that if we sit there on that thread and we wait for input_stream.read to finish, we can't move forward until the network socket gives us bytes back, right? That thread is stuck. Nobody else in the system can use that thread. And this is a problem because if we're wasting time, and threads are precious, then we can't scale the system up, right? So let's take an example here. Let's take a quick look at an example here. I'm going to steal an example from my friend, Professor José Pomar. Okay, he's a professor in France, a Java developer advocate at Oracle, and a legend. So I'm going to take his example. Okay. Here we go. Actually, I just create a bean up here. Okay, bean application runner, return new application. And what I'm going to do is I'm going to create a bunch of threads, okay? A new array list thread, like so, for var I equals 0, I is less than 1,000, or whatever, I++. And I'll say var threads.add thread.of platform. That's equivalent to the regular kind of thread that we would have created at any time in the last 27 plus odd years, okay? And in this thread, once I've got all those threads, we'll come back to that, I'm going to say for var t threads t.start and then .join, okay? Join, good. So that's weird. Okay, good. So now I've got that. So now in this thread, I'm creating these new lambdas. What am I going to do? Well, I'm going to capture the current index. Okay, or first equals I equals 0. So if I'm in the first thread, then I want to take note of the current thread name, and I'm going to store that thread name in a set. So sets are deduped by default, right? So, and I'm only looking at the names for the first of the 1,000 threads. I'm not going to bother with all the other ones. So if first, then observed.add thread.currentThread.toString, okay? And then I'm going to sleep 100 milliseconds. This is a blocking operation as well. If you put your debugger here on line 43, you'll have to wait a second before you can go to line 44, right? And that's the whole nature of sleep. It's a blocking operation. And I'm going to do this 4 times. So I've got it once, twice, thrice, 4 times, okay? So there you go. So I've got this program. Let's go ahead and Command-Shift F9. We'll restart the program. And when I have to also print out the results. I forgot to do that. So system out observed. Okay. Oops, I restarted by accident. Oh, well, who cares? Okay, so did I do something wrong? There it is. So there it is. There's the result, right? It is as you expect. I monitored the current thread name on the first thread. Well, it turns out that if you ask for the current thread name on the first thread, the thread name is the same each time you ask for it. That makes sense. That's the physics of Java up until recently. But this is a bit of a shame because that means that we're stuck. The Java runtime is stuck waiting for this code to execute, and that thread is not in the thread pool available for somebody else to use it. Wouldn't it be nice if the runtime could detect blocking operations like this and automatically move the thread back to the thread pool and store this in RAM and then just wait until, set a timer, so that when the blocking thing is done, we get put back on a thread to process. Well, that's what reactive programming does. But I don't want to rewrite this to use reactive. So now we have Java 21, we have virtual threads, right? So instead of using of platform, I'll say of virtual. Command-Shift F9, just restart it one more time. And this time, friends, okay, There you go. Virtual thread 1. It's the same virtual thread, but you can see it's being moved to different actual threads through the course of the program. I'm still in the same thread. I haven't changed the code at all. But magically, the runtime has moved my logic from one actual thread to another. When I was busy waiting for 1 second, I wasn't sitting on the thread. Somebody else in the system could use that thread. This means that now my program, just by using Java 21, has much better scalability characteristics. This is a huge deal. Now you can maybe scale down your instances. You don't need so many services in production. This is free money. This is why I say it's irresponsible to be using anything less than Java 21 if you can help it. This is free money. You should tell your boss before you do this, you should say, boss, I think you should give me part of the profit sharing, but I have a big idea. If it works, I want part of it, okay? This is a good way to make friends. So you've got this. You've saved resources. This is a little bit of work, though, and this is also very low level. You're creating threads, by yourself. Most of us don't do this. Maybe you'll use an executor service, and you can do that as well. You can say new virtual thread per task executor. That's a virtual thread executor. It's not a pool, though. It creates a brand new thread each time. You're not pooling threads. But even there, that's a little low level, and so maybe you don't want to do that. Maybe you just want Spring Boot to do it for you. Well, if you're using Spring Boot 3.2 and later, you can do that like this. Now, everywhere that there's a thread pool required in the web and the security and integration batch, we use the virtual one now. Now you get scale across your application. Easy. All that was very, very simple. So now I think I'm ready to think about moving this to production. And friends, I want this to be as production worthy as possible, right? I want it to be fast. And so there's a couple of things I can do here. First, I need to care about production concerns like putting it in a container. Well, of course, here we can just use Buildpacks, right? Buildpacks are a way to containerize Java applications. They answer the question, how do I take an application and get it into production? Remember, friends don't let friends use Docker files. Don't do it. Just use this. It's faster and more secure. By the time you have finished writing your home-crafted artisanal Docker file, you've got a CVE. Instantly. The same second you finish it, there's a CVE against it. Don't bother. Let the community do it for you. This is faster and a better result. And Spring Boot supports it out of the box. You just go to the command line and you can say, Maven, skip test, because I didn't write any test. Anyway, Spring Boot build -image, and that'll do that, but we don't have time for that. The other thing I want to do is to turn my application into as optimized a form as possible. And Java is already pretty fast, right? It is really fast, and I think it's also very efficient. This is well understood by looking at this blog from May 20th, 2018, before the COVID pandemic, or BC. And this blog asks the question, which programming languages use the least electricity? And it's a very interesting blog. You've got some very interesting results here. Normalized global results for energy, time, and memory. And we're looking at energy in particular here. And you can see that C is the most efficient language. That is to say, given the same program with the same basic operations, C is the most efficient for machines, not people. Okay, that's very important here. For the machine, it's the most efficient, okay? 1.0, okay, simple. Rust, zero cost abstractions, doing quite well, good on ya. C++, tooey, disgusting, moving on. We've got Ada, but nobody cares, and then we have Java. And Java, let's just say Java is 2.0, okay? Round up, simple math. Java is twice as inefficient as C. Is that fair? We're on the same page, okay? We go down this list. We can see there's some other languages. Swift, okay? iOS, Mac, you got that? That's Swift. C#, okay? Good stuff. Go away. You've got these monstrosities of languages. Look at that. I don't understand how JavaScript and TypeScript can be so very divergent. One is 5 times worse than the other. How is that possible? Makes no sense at all. These two, tooey, moving on. And then JRuby and Ruby. Look at this. JRuby is Ruby on the JVM. And Ruby is Ruby in C. And JRuby is actually almost a third more efficient than the C version. The JVM is an amazing, amazing platform, my friends. It's always been. Don't let people tear it asunder. It is an amazing, amazing place. And you get that kind of optimization just by being on the JVM. Whole world memory optimizations. And then you've got Python. And this makes me really sad because I love Python. I've been using Python since the 90s. Bill Clinton was president when I first started learning Python, right? I'm a big fan, but this is not acceptable. Think about what this is. Let's round up 76, okay? So I'm not really good at math, but you know who is good at math? Freaking Python. So let's ask it. 76 divided by 2 is 38. So what that means is if you have a program and you run that program in Java and that program takes electricity and that electricity creates carbon because the manufacturing, the production of the energy creates carbon, and that carbon goes into the atmosphere and it kills one tree. The same program in Python kills 38 trees. That's a forest. It's a forest. It's not okay. It's almost as bad as Bitcoin. We really need to fix this. Something needs to be done, especially now that Python's powering all of the AI stuff. So anyway, that's neither here nor there. Let's get back to what we're talking about, which is I want my Java program to be as efficient as possible. And so one thing that we have is we have the just-in-time compiler, which is amazing. It retroactively compiles code that it sees after many successive runs into native code. And that works just fine, but I want to ahead of time, I want to turn it into native code. And to this end, there's a great project called GraalVM. Who's heard of GraalVM? GraalVM is awesome, okay? And they have a just-in-time compiler that's also really good just by itself, but there's also a native image compiler. And you can use the GraalVM native image compiler, but the problem is you have to provide a lot of metadata to the compiler to tell it about the things that involve reflection, JNI, serialization, JDK proxies, and something else, right? I forgot what the other one is, but there's a fifth one. So you have to tell it about all these dynamic, class path resource loading, right? Anytime you do any of that kind of stuff, you have to tell the GraalVM compiler about it. And this is painful because it requires you to write JSON, right? And I don't like this. There's a couple reasons. First of all, you have to write a lot of JSON, which is annoying. And then because you think about it, all the places you do these dynamic things in your program require JSON. That's the first problem. The second problem is it just sounds stupid. I can't say the word JSON to adults and not giggle a little. It just sounds like a stupid thing to say to somebody else about technology. I speak French, and in French we'd say JSON, which is way cooler, right? And then I was in Taiwan. There they have a language called Hokkien, and in Hokkien you have Jingsong, which means happiness, right? So either a JSON or Jingsong. Pick your team, but this cannot stand, okay? So the question is, who's going to write the JSON for us? Not me. I don't have enough time to do that. I don't even have enough time to finish this talk. So instead, what we're going to do is we're going to ask Spring Boot to do it for us. There's a nice mechanism in Spring Boot 3.0 and later called the AOT engine. Okay, and I'm going to do native compile, and we're going to let that run in the background there, almost there. And it's going to take a while. That's the only problem with this. It does take a long time. And unfortunately, what that means is that now I am part of this crowd. I understand this joke. This is the famous XKCD cartoon, compiling, two programmers goofing off, swashbuckling, right? And the boss says, hey, get back to work, compiling. Oh, carry on. I get it now. I understand this joke. I didn't want to understand this joke. I thought this was just a C++ people, right? But here we are in 2024. It's a weird year. This is now us. And it makes me very sad because I don't want to understand this joke, you know? And it takes so long to do these GraalVM native image compilations that I get bored. I stare at the wall, and sometimes I start to hum, or maybe I'll look at the ceiling or look out the window or something, and I start to hear theme song music in my head. And it got so bad that actually, I started to think about elevator music, the music you hear when you're in the lift. And I started to think, wouldn't it be great if we could all hear elevator music? So I went to Oracle and I said, hey, Oracle, please play elevator music during the native image compilation process. And I said, I already hear elevator music in my head when I do these sometimes long-running compilations. I'd just like everybody else to hear it too. Thank you in advance, and I appreciate your amazing work, and I really do. And so I got some great responses here. One from our friend over at Red Hat, Andrew Din, who's a distinguished engineer on the Red Hat Java team, OpenJDK project reviewer, Byteman project lead, and a Graal developer. And he suggested, can we make it this elevator music? I'm not going to click it because it goes to a YouTube video for some music from the GoldenEye Nintendo 64 video game for the James Bond movie from the 1990s. It's perfect. It's perfect. And then Ivan said, I would add that using beeps helped with development time, right? That makes a lot of sense. My stupid microwave will go beep when it's done. Why can't my compiler, right? This makes a lot of sense. I love that. And then I got this response. This response is from Fabio Niepaus, another one of my favorite doctors. He's a researcher on the GraalVM team at Oracle Labs and a doctor. And he responded very kindly with this response. He says, thank you for your feature request, Josh. The problem with playing music during the compilation process is that it's just fixing the symptoms, and we've been and are still working on the cause, making GraalVM native images more efficient in terms of time, memory, and CPU consumption. Okay, go on. Anyway, I have prototyped the -- Josh Long mode. So what this would do is you'd run native image -- Josh Long mode, and then it would print music brought to you by Josh Long, because you're going to hear music, right? That's the whole point. You want to know what's happening. It'll say music brought to you by Josh Long. Then you want something nice to look at, and you get this, right? So there you go. Like, look at that. Much better. This will be merged in the compiler, I'm sure, sometime soon. Anyway, I forgot what we were talking about. Right, the compilation. Yes. So it took 46 seconds. That is awkward. That was a long time ago. Let's see if we can run it. Target du-hs service. It's 101 megs. I'm going to run it here. The port's blocked. Okay, the existing run. Okay, go there. Good. Okay, it doesn't have a database. Remember, I'm using the Docker Compose support in Spring Boot. I didn't have to specify the credentials. I'll go here. Okay. Log in to my folder. Okay, and then I've got a script here called run. It's going to export environment variables for a Docker Compose image. So I'll do Docker Compose up. I've got another Docker Compose file there. Docker PS. And then I want to kill this existing one because Spring Boot started it up for me. Okay, and then this one, because I'm not sure if that's the same. RMRF, that one. Okay, Docker PS. So now there's no Postgres. So I've got this Docker Compose file. Let's do that. Docker Compose up. Okay, here we go. And then I go back to the same directory and I do run. Okay, desktop talk. Log in again because I've got dear env prompting me. Okay, and then I can just run this program, right? Run. And there we go. What happened? Data unpaged. Well, that's a bummer. Did they change? Well, you know what, friends? We're already so late. I'm going to go back to something I know to work. I think we found a bug. Like, when in doubt, roll it back. Okay, so here we go. Local. Go to the command line, terminal. Maven, D, skip tests. Native compile. P native. Whew, this is embarrassing. I don't know what happened. I don't know what that bug is. I don't care. We're going to fix it by going backwards. Come on. This does take an agonizingly long time. Almost there. You can see it takes a slack's worth of memory. Did you see that? Where'd it go? Where'd it go? It puts it in very small font, so like you almost don't notice that it's happening. But like I could load Slack in that. It's 27 gigs of RAM. That's almost a Kubernetes. Like that's a lot of RAM. Come on. 8 out of 8. It's going there. It's almost done. Fingers crossed. Et voila. Okay. So now, take 2. Voila. Okay. So there's the application. Start it up. Let's try again. Start up again. So now you see it's 0.094 seconds, right? 0.094 seconds. It does the virtual threads. I don't care about how long the startup time is because this is not a Lambda, but let's grab the process identifier, PS-O RSS 70041. So 117136. That's in kilobytes. So divide by 1,000. That's 117 megs of RAM for an application that has a full web server, data access stack, all the code. I'm talking to the freaking Singularity. I've got all that stuff and 100 megs of RAM. How much RAM does your application take? Probably more than that, right? 10 times. This is a good deal, friends. We live in an amazing time. I built an application that is now production worthy. It scales up. It has virtual threads. I'm using AI. I've got all that stuff, and I'm doing it in 110, 120 megs of RAM. And all I had to do was upgrade. It's an amazing time to be a Java and a Spring developer, my friends. With that, I really, really hope you got something out of it. Who learned something new today? Wonderful. Who had fun? Wonderful. I want to thank you so much for being here. You know, it's really good. Aren't we lucky? Look where we are. Good stuff. Thank you, everybody. Have a wonderful day. Thank you so much. Find me online, you know. Come on, YouTube. It's going to be great. We'll hang out and do tubes and stuff. All right. Bye.